not too loud. Thank you for giving me the opportunity to share a little bit about what's called today coloring sustainability. I think I'm very happy that I can share that around sustainability, things are happening around the world, but also in Thailand, and very close to everybody's home here. So, as Alex mentioned, I work for Luncheon. Luncheon is a knitted polyester textile manufacturer working for the sportswear industry. We're part of the Ye Group. We believe that we are the global leader in pioneering water reduction in our industry, and the products that we sell from this technology are sold under our own trademark brand name, Drydye. So, the big story is that textile industry is the second biggest polluter of drinking water in this world. 20% of all wastewater created globally comes from the textile industry. To give you an idea about how much water that is, just the water used to make our clothing we are wearing today, globally, consumes the whole Mediterranean Sea every 2 years and spits it out as wastewater, like Alex mentioned, which is very difficult to clean up again. So that's a huge amount of water. So even for us, medium-sized textile mill, I'll show you later some data, we use a lot of water today. So if you would count up all these factories together all over Thailand, all these factories together all over the world, just to give you an idea on how big the issue is. I mean, this is from Bangkok Post yesterday. Water shortage will hit after Songkran, right? The Guardian, also Wall Street Journal, writing articles that actually the next global conflicts probably will no longer be about oil like the Gulf War, Kuwait, Iran, but will be about water. And already today, in China, water is the biggest environmental concern people have over any other kind of pollution, because it threatens the livelihood of most of the people still in China, agriculture. And I think the same is still true in Thailand. I think most jobs are still in the agricultural industry. Yeah? And if water shortage got hit already after Songkran, and the rains are only coming 2 or 3 months later, that's a big issue. Right? And we as an industry, not only textiles, but I think many other industries are taking up a lot of that water that probably has a much better use. Okay? So, the group we founded in 1998, family owned, second generation. The Ye family the father came over from Taiwan. The kids came with him when they were 3 to 5 years old and now run the business. We're making mainly sportswear fabric for people like Adidas, Reebok, Puma, Under Armour, Mizuno. I think most of them are similar faces. 52 million yards per year, which is like a medium-sized mill. About $60 million US turnover, right? But the water we consume is 1.3 million cubic meter per year. And I looked up some statistics that the average household the average person in Thailand consumes around 292, let's say 300 liters of water per year for personal use. So what we use as a factory is enough to support a city of 13,500 people for the whole year. So if you would multiply that by, every other factory around here that uses water, and globally, I think we take away a lot of water that could be used for other purposes, right? So within the group, Ye Group, just want to place it, what's in blue is 100% owned, what's in red are joint ventures. So I just want to point out the last one called Dyco Textile Systems. Dyco Textile Systems is the company we co-founded with a Dutch company called Feco, whose background is high pressure CO2 technology. For example, they make equipment to extract coffee taste out of coffee, or extract medical components out of marijuana, right? And their background, their idea was, well, if we can use CO2, high pressure CO2, to extract things, we should be able to use it to deposit things. And we're first looking at textiles. And our owners met the people of, I think, 2007 at a textile machinery fair where they were exhibiting with a little video what they had developed at the university as part of a PhD degree for the owner. And we ended up co-founding the company and bringing in our experience of the textile industry, combining with their knowledge of high-pressure CO2 to bring the first commercial machines to the market. Because the technology of dyeing in high-pressure CO2 existed already over 25 years ago on a lab scale. But nobody in that time had been able to bring it to production size equipment. Mostly because the pressure we use in the vessel is 250 bar. And you need to circulate that CO2 at that high pressure run. So you need to have very complicated pumps that can operate at such a high pressure. It's very technical, something for engineers, but okay. So maybe very quickly, this is a little video that tells a little bit about the philosophy of our company and provides a good background to understand what we ended up doing.
If you look at anything we do, it's always about trying to be more eco-friendly. Our family name is Ye, and then I say, well, it might have something to do with our DNA or something. And you know, being Ye. Ye's in Chinese means the leaves. We decided to design a logo for ourselves, and that's the two leaves because it's the two brothers. My father was very innovative, trying to do more than what he had at that moment, and always pushing ahead. All that stuff becomes the inspiration for driving the business forward. We try to find new things that make our people excited and challenge them, so that they bring out their creative side of their mind. Is there another way to do things better, faster, cleaner, more user-friendly, easier for people to work on? Then we start to think about all the other innovation ideas. The people, to us, is the most important things that even sometimes we have the technology, but if you don't have the people who understand and who have the same ideas as what you are doing, then whatever equipment we buy is a piece of steel. But with the people who understand that and have the same concept, then we can make a difference.
So it's this kind of philosophy of how can we do things better, cleaner, that led the owners to invest in a disruptive technology or a disruptive innovation like CO2 dyeing versus water dyeing. Because historically, the amount of water used in our industry went down, right? But the slope is not a straight line. It's just every out. And this technology allows us to just drop to zero. Okay, so drying with our water just fits in our all-over environmental policy of trying to be more environmental friendly, be more sustainable on different levels, and no water dyeing fits into that. Because, sustainability is in our, I think I missed something here, okay, no, something disappeared. It's part of our DNA. Today, any business, I was talking to Alex before, I think it's the right thing that sustainability is part of a business school. Because sustainability today is not a nice to have anymore, it's a must have. It's about economics. It's about a tool. It's about, will we be able to be around as a business 5 years from now, 10 years from now? Will we be competitive? Will we be able to operate in the environment that we are placed in? Are we able to satisfy our stakeholders, the people living around the factory, living around us? Will be able to exist. So, as general sustainability strategy for the group, 3 pillars: water, energy, and waste. So, focus on water. We want to, by 2025, want to have all our fabrics manufactured by water reduction technologies. It's a little bit of a safe statement in the sense that we're not really sure if we can do everything in CO2 by 225, but at least we will not be using fresh water. We will be using recycling as other technologies for what we have. But it's, say, energy and waste. I mean, water is a waste in the present technology, in the present state of business for most people. So we want to, whatever water we still use, we want to create a closed loop and recycle. And also any kind of other waste from our business. Yeah? So sustainable is a must for the survival. So specifically now into what we're doing here, this new process and machine for water and chemical-free dyeing, because there's two legs to it. It's no water and no chemicals. Yeah, and these are pictures of the actual equipment. What's happening today? What's the traditional industry about for those people who don't know how textile dyeing works, right? We knit a fabric, like your grandmother used to crochet, but then with machines. It has oil in it from the machines that need to be kind of cleaned, which we call this thing called scouring. Yeah? And then to dye polyester fibers, we need to go in a dyeing machine, put 2 to 6 bar pressure because we need to get to 125 degrees Celsius. And we use clean water, dyes and chemicals in the equipment to color up the fibers. At the end of the process, we have wastewater, which has dye residues and chemical residues. The chemistry is there because for polyester, water is a barrier. Yeah? The dyestuffs themselves are petrochemical products, pigments. They are hydrophobic. The polyester fiber itself is hydrophobic. So we need, in today's industry, a first set of chemicals to make the dyestuff dissolve into the water, and then a second set of chemistry to make the contact between the water and the fiber to be more efficient, to let the dyeing to happen. The problem is that chemistry afterwards ends up all in our wastewater, and is very difficult to remove and break down, right? And because water is a barrier, the efficiency of the process is relatively low. We have normally about 85 to 90% of the dyestuffs that go from the water onto the fiber. So we have 10 to 15% dyestuffs left that also go with the water. There's a lot of press about the Greenpeace campaign, which they call zero discharge or the clean clothes, right? Which talks exactly about all these chemicals used in our industry that accumulate in the wastewater, that are not being broken down and end up in the seas and accumulate. So there's no natural way to break these things down. So there's a whole program going on trying to change the chemistry to something that's more environmental friendly, but our process takes them completely out. Okay? And actually, after dyeing, we have a rinsing washing step to clean off the dyes that are not really fixed. So again, we create wastewater with dye residues, and at the end of the step, the fabric is wet. We need to dry it before we can roll it up and sell it. That's the technology today. In reality, depending on the technology that you use, older or newer, we actually use 50 to 150 liters per kilogram of textile. That translates later on in about 25 liters to dye one t-shirt. We need 25 liters of water and all these different steps to color up one t-shirt you're wearing. Okay? So, what is happening in the CO2 dyeing, right? Actually, in the CO2, we could also do the scouring. We're not doing that today because of limited capacity. But, as I said before, water is a barrier. CO2 is a hydrophobic inert gas. And that, because of that, it's a facilitator for the dyeing process. So all the chemicals that we had to make the dye stuff go into the water, we can leave out. We use the pure pigments, the pure color. Yeah? And we have the same dyeing process, circulation in a machine, dyeing up the fibers, but at the end of the day, I have CO2 and some leftover dyes, instead of 15 to 10, only 5%. But when we bring the pressure up again, the solid dyes easily separate from the CO2 gas. And we can recycle again, and the gas we can recycle again. Right? And the same when we do a machine rinsing to clean out the machine before the next step. We have some dyes coming out, but we can easily separate so they don't end up in the environment. And the process is dry. I don't use energy to dry the fabric afterwards. So it's very technical, but basically things to remember is by taking out water and replacing it by CO2, we have no wastewater, no chemicals, and less energy. Actually, the numbers from an LCA study that we did point towards next to no water, right? 50% less energy, because the dyeing cycle on the CO2 is also shorter. The drying afterwards is not needed. and also 50% fewer chemicals. There are still chemicals. The dyestuffs themselves are chemicals, but they are either in the fiber or solid waste, which can be disposed of in a proper way instead of in water. Yeah? And next to that, of course, you know, no more water. So the picture of 25 liters to color one t-shirt is reduced to 0. So just to limit up, no water usage and of course no wastewater. I mean, as an example, actually we're very happy. Recently, we got a swoop from the Thai army and the local authorities who had received complaints from the villages around our factory about polluted water. And actually the whole area, there are about 65 factories dying or creating wastewater in one way or another and needing to have a wastewater treatment plant before releasing it into the environment. About 35 of them were closed down after the inspection for 2 weeks to 4 weeks. Okay? Which is very good because we believe that's the right way to do. Yeah? So we also have 50 to 75% less CO2 emissions. That number is bigger than the energy because the wastewater treatment itself is actually causing a lot of CO2 by itself, right? Which is also now excluded. Yeah? And of course, no chemicals. Good. A little movie talks a little bit more about, you know, the achievements.
Conventional dyeing today takes place at what we call a value called liquor ratio. That ratio is probably about 8 to 1. That's to say we use 8 times more water per process step than the weight of fabric. Around 20% of the world's industrial pollution is created by the textile industry. Dry dyeing offers a chance to impact on this very dramatically. Dry dye uses no water. Some aspects are similar to regular dyeing. In this case, for dry dye, we exchange water as the transportation system for CO2. The dye stuff is soluble in CO2 and is distributed very highly efficiently through the fibre, and this enables us to make the dyeing process. In a very short time, we have taken the world's first prototype machine, achieved industrialisation, achieved the first 1 million yards of total production, and now we continue to optimise and further develop the process. Dry dye could go beyond the capability of conventional dyeing. This represents the biggest step change in technology that I've ever witnessed.
So, this is actual picture of the equipment in our facility. No water around. Big machines, steel walls from this size to work with the pressure. Actually, when we brought the machines in the first time, we could not register them with the local government because there was no category for 250 bar pressure. So we had to work something out. The safety certificates we have to arrange with Bureau Veritas from the Netherlands because the local Bureau Veritas is not qualified, or anybody is qualified to certify the equipment for us. So what are our plans today? Up to today, we have already a capacity about 6 million yards, which for our industry is about 1.5 million kilograms of textile per year that we have the capacity for. We will double it up within the next year, and the target, aspirational target, is to replace all our capacity, which should be 60 million by 2025, by CO2 dyeing and no more water. We honestly believe that this should become the new standard in our industry, but we're not fully in charge of that. Okay, let's hope that we can achieve that. That would be, I think, great for our world. So, customers that we're working with today, biggest customers I have for this product is Adidas. For all our customers, on every product that they make using the fabric, they are using our trade name, Drydye, on the outside of the garment. So our target is to create or have Drydye as what we call an ingredient brand. like you have with a Gore-Tex on an all-weather jacket, or you have with an Intel as a chip in a computer. Yeah. Adidas biggest customer. We do marathon products for Mizuno, iStudio, the local Apple dealership. Yeah. The new uniform for the staff introduced 1 or 2 months ago is made from Drydye fabrics and has the logo on it. Right? Peak Performance is an outdoor and golf brand from Scandinavia. We sponsored the TMB Partra 2015 with our fabrics, also with Drydye. And Marks is a menswear company from Canada. So these are existing customers. We are working on more. It is a challenge because many of these brands want to be me too and not me first. They're all a little bit scared. They all understand that they need to do more on the environmental side of their products. And we actually are able, if we plan the business well, to sell them the products from this technology at the same price as we sell them the products from conventional water dye. So that's not a barrier, okay? But still, you know, it's in a way slow. We started in 2011. We shipped since 2011, we shipped about, this is some products, so this is the logo, some Adidas shirts with the Drydye logo on. Actually, this is our Dutch partner, Professor Oerlee, who built the first sample machine at his university, Technical University Delft in the Netherlands. This is the London Olympics, where the winner of the marathon wore a fabric dyed in CO2. Okay, so this is my end slide. Maybe just go back here. Overall, these customers over the years, we shipped already since 2011 more than 5 million yards. Well, that's not little, but in the amount of clothing you see globally, it's a little drop in the sea. So it's our ambition to widen that. We know we will never own all the capacity in the world. So Tyco, who builds the equipment, can sell and has sold some equipment to other manufacturers. But so next to my 3 machines in Thailand, there's 2 machines somewhere in Taiwan. And that's all for the moment. Global capacity. So global capacity, Thailand has about 66%. And we will increase that even more. But of course, it depends on our ability to introduce this product to our customers, our branded customers like this, which and we had some discussion with Professor Fenn, from a marketing point is very difficult because we are normally part of the supply chain, working with the buyers on the brand side. But to introduce something like this, we need to be able to talk with the people who are creating the product, who are designing, who are setting up merchandising the whole line. So that was for us a whole new value. So that's it what I had to share, but I hope that we have a lot of questions and things to discuss about. Thank you. Sure.
My question is, how is the ability of the fabric to maintain its color get affected by the new process?
Not at all, because we don't change the fiber, and we don't change the dyes, the pigments, the colorants. We only have changed the process to bring dye stuff onto the fiber. So once it's there, the fabric behaves exactly the same like what you have today.
You know, sometimes you buy like a lower quality clothes from a market versus something you buy at Adidas, and when you wash it, all the color just comes out.
Yeah.
Is there a way to improve this through the CO2 dyeing process?
No, it's just a badly executed process. Because that fabric, what you find for the cheap brands, is probably my B-grade fabric that I sold off because it didn't meet the standards that it should be. Okay? If the process is not executed well, then you will have problems with what we call color fastness, that the color bleeds when you wash it because the fibers are properly, the colors are properly fixed, or it could shrink right too much, or it could have snags, or whatever. So yeah, a lot of the products that you find on the local markets, no branded, is probably made with B-grade fabric from people like us. Sure.
You said the challenge for you as coming from a supply chain is that you have to inform the brands to get the products under the CO2 process. Now, if the fabric is the same, so you wouldn't even tell the difference of the water process and the CO2 process, then what's the challenge from a supply?
The challenge
is it more expensive?
Okay, already today, the operational cost of the process, right, the pure dyeing and putting the fabric through, is cheaper than dyeing it in water. Because the amount of energy is used is less, the water is not there. But the investment in the equipment is very high. So the amortization part is relatively high. So I can make the same price as the conventional dye if I can have a high output of my equipment. That means a long production run. So there's conditions around the same price. There's conditions about minimum order size. Right? If the minimum order size reaches a certain volume, I can distribute my amortization over each yard in such a way that the total cost for the customer is the same. Right? If we go below that, then I need to charge more to be able to recover some of my investment and then later on expand it.
Actually, so how different is that this moment?
What we also do, when we try to promote Drydye as an ingredient brand. So it's part of my marketing cost to lower the price. Yeah, to introduce it to the market. If not, if customers don't want to use that, I mean, many customers are not eager to use an outside brand on their product. Yeah, unless it's very famous. Yeah. Everybody wants Gore-Tex, everybody wants Intel. We're not there yet, we're very far from that. I mean, if I get to that point, no more discussion. If there's no unbranded, I would be asking for 15% more. But that is the same level of difference in the market today between using virgin polyester and recycled polyester. There's a lot of recycled polyester already in the market coming from post-consumer water bottles like this. Okay? And it also has a price difference at a similar level. So it's more about, people are sometimes scared about new technologies. They have a business. They think that the new technology might have hidden disadvantages. But of course, the question, if you don't try, you don't know. Right? I had one customer who wanted to try out, and he said, we'll bring in our line one pant in color black, and we will do your technology, and the rest we do the same. The old one. I said, well, it doesn't help because you're never going to have any experience about this technology, good or bad, by just doing one product. You will not have any customer feedback or consumer feedback, right? I had another brand, actually I forgot it. We work with Decathlon too from France, and they did it in a much smarter way. The innovation people looked at the collection and said, okay, this group of fabric we will do in your technology. We will not tell our market that we are introducing a new technology in the first season. We'll just put it in there. And then we make an evaluation after 1 year and ask the people, well, this is what happened. Did you see any difference? Right? And if it's from a market acceptance point, there's no difference, or maybe, because it's also not being marketed, right? It's not being marked. If there's no difference, then you can talk about the ecological benefits of using this, because on all the other parts, there's no difference for the consumer, and then you have a selling point. So that was a much better way. But different brands think very differently about how they want to deal with it. It's also very different how people in Europe think about it, and how people in the States think about it. Okay? I would say the attention in the US market for sportswear on ecological subjects is still very, very low. Only people like Patagonia, but Nike a little bit, but everybody else, very little. Europe, much more alert, much more. People are recycling since a long time, much more reliant. Japan, so we work with Mizuno for Japanese products, still not very high on the agenda from the consumer. But I know we are very early, and I hope that many other businesses have other initiatives around sustainability going to the market, which will actually help us too. Because then we are part of the biggest story and not out there alone carrying our little flag like a Chinese tour guide at the Grand Palace.
So you mentioned you wanted to make this kind of the norm in textile manufacturing. Do you plan to license out the technology, or what's your...
So everybody can buy the equipment.
Okay.
And actually, we let everybody use our Drydye trademark because it would have benefit to see the trademark on products that I cannot produce by myself, like woven polyester, right? For shorts and for pants and for jackets. We are not making that. Somebody didn't want to use the brand name, it's fine, it's great for me. Yeah. What it also allows on the other side of the market, from a market approach, is in sportswear and in general in consumer goods, the pressure for more collections, more variation is getting higher and higher. And it also means from the supply chain that we need to be quicker and quicker. But manufacturing in Asia has a long transportation lead time to, first of all, from Thailand, which is losing its garment output because of we're not part of any FTA, free trade agreements with Europe. We're not able to negotiate. We're not part of any talks with USA on TPP, Trans-Pacific Partnership, because we're not able to negotiate. We are losing business. So my garment manufacturing, or the people that make garments out of my fabric, are moving to Indonesia with a big population, moving to the Philippines with already duty-free access to the European market, right? But that it gives me an additional lead time disadvantage of 2 to 3 weeks. So we will go and invest there. But with this technology, we can go even into Europe or back into the States because I don't need a special license to have a wastewater treatment plant. So we can bring manufacturing back to the consumer with this technology. So we hope that maybe in 5 years from now, there will be a Drydye plant in North Carolina and a Drydye plant in Europe. Because I think as a bigger picture, everybody sees the economy is localizing back again, right? With the digital age and stuff like that. So we need to produce locally again. Because the wage differences, they will all be leveling out. And of course, reduced transportation and reduced time is all part of our cost, is all about sustainability also.
In policy level discussion, for example, working in Netherlands where the technology is from, is there any political incentives on using this kind of technology versus a traditional way? For example, like maybe tax exemption because it's environmentally friendlier than traditional one. Is there any this kind of policies?
Very honestly, there probably are, but we have not explored. We have not gone through the process of investigating with BOI or something like that. But on the receiving country side and looking at duty reduction, no, there's none. Okay, there's no incentive on that side. There would only be incentives on importing equipment and things like that.
And then follow-up question: is there any move on introducing this technology to the policy level as well? Because then I think then if the intention is to introduce this as a norm for the dyeing industry, then I think policies and political like government side should play a role as well, because they will be the one standardizing.
Well, we believe that we don't need that. There is no need for that because the economical benefits will be strong enough. You know, I think when you push people to move, you automatically get resistance. If the incentives to move is cost, and sustainability in this part is cost reduction, right? It should happen automatically. It's our task to continuously prove that the technology works, that the technology is improving, that the technology will be covering other fibers, because today we only do polyester, right? But it can be going into nylon, going into cotton maybe in the future, right? That's the only way that we can say that CO2 dyeing, water-free dyeing can become the next norm, industrial norm of our process. But that's only because it's the best process available, not because some policy said you should do that, right? Sure.
Does textile sustainability affect fabric performance?
It should not. Okay? It should not. Because you don't want to, you want the sustainability to be a benefit for you as a manufacturer, because you have a cost advantage, and mostly in the longer term, right? Because you are preparing yourself to have, like for this process, today, okay, the operational costs are already lower than dyeing in water. But the cost of water will be going up, and I'm independent from that. The cost of energy will be going up. I'm not independent, but less dependent, because I only use 50% less, okay? The cost of CO2 is actually stable, because CO2 is well, we recycle 95%, because to get the last 5% out of the machine, we would create so much CO2 on the energy side, which is more than what's inside. So, but CO2 is a byproduct from the petrochemical industry. So the cost of CO2 is basically the cost of the transportation. That will increase a little bit too, but the gap, the cost gap will be getting wider and wider and wider. Okay? So that's what you invest in the sustainability part about. If it is a disadvantage for the consumer, then in principle it's a no-go. Right? Because people don't want to give up what they have. Yeah? If it's a benefit for the consumer because they have a product that performs as well as what they buy today, but in addition they are aware that by purchasing this product they're contributing to environmental concerns that they have. You know, marketing or selling products is emotional. Professor Ferry can explain it very well, right? It's not a rational decision when to buy a product. So with sustainability, from our side, we look at our cost picture today and in the future, and on the consumer side, we try to talk to their emotional side and their concerns about the environment. I mean, the numbers in China are staggering. You know, in China it's very difficult to have a protest, right? But when there's a problem with the environment, they have thousands of people on the street. Okay, it's their main concern. And within the environmental concerns, water is their main concern, because it's drinking water. There's water for agriculture, right? So if you go to China, we try to work with Li-Ning, for example. Right? And Li-Ning is quite backed up by the government. They have very strong connections there because they want to show, buy this product and it will help you clean up your rivers. Yeah, you're talking very much a very emotional side of the things. So that is very difficult for us as somebody being traditional in the supply chain, how to talk directly to the consumer. So we try to have our customers do the talking for us by co-branding, yeah, and offer them as a benefit.
On that note, it is actually possible to make sustainable and high-performance fabric, right?
Yes.
Are there instances where both are mutually exclusive?
There is. Very specifically, water repellency, right? Where you make fabrics repel water and resist rain. The chemicals used traditionally in that we call C8 because they have 8 atoms of chlorine. And these are one of the, they don't break down in the environment. So when we process or when you wash those clothes, always something will go into the water. So globally there already is a ban coming up on this type of chemistry. The new chemistry developed we call C6. It has less chlorine. It's still harmful, but less harmful. But is not as performing as the old one. Right? So either you use more of it, which is also not good, or you have as a consumer to accept that in a heavy storm, where before your old jacket stay dry, this jacket, some water will come through. And the next one is a chemistry that doesn't use chlorine at all, is even performing less. Right? So this is a case where sustainability and performance are not going hand in hand. But the case for not using this chemistry is so strong that you have to go away from it. Okay? So, but then the solution maybe to that is to try to find other ways to apply the chemistry so that none of them ends up in the water after into the process or in the environment, and none of it is being released when you wash your garments at home. Because then it doesn't matter, right? Because then the chemistry stays contained with the product. It doesn't affect your skin. So, there's two ways to look at it always.
Is that similar to the case of PFCs, like perfluorinated agent?
That's exactly the same case. Yeah, it's PFCs, they call PFCs.
Any questions from the back table? That's very quiet back there. One last question? Okay.
Sure.
And do you think the process with Drydye could be made with natural colors instead of chemicals?
In principle, yes, because the natural colors are also pigments.
Yeah.
Yeah. So in principle, yes. It depends how.
Have you tried yet?
No, we have not tried yet, because it's quite technical. The solubility, when we put CO2 at 250 bar, it's neither a liquid or a gas. It's so-called supercritical. Yeah, and the solubility of the pigments is there, but it's not that high. So, and to do that, we need specific particle size, and I don't know how it would work with natural colors, but certainly something to explore.
Okay, good. Well, let's thank Peter once again.
Thank you very much.